I welcome you all to this session of engine system and performance, and today we shall discuss about different types of control system. If you try to recall, in the previous class we have discussed about the engine management system, which is also known as electronic control unit, and we have seen that the sole objective of this particular system is to coordinate the functionalities of several subsystems, essentially to increase the engine performance at a reduced emission level, to ensure safety of the engine as well. And we have seen that there are several basic objectives like fuel injection control, spark advancement control, emission control, speed control, all these things are basically monitored by the engine management system or electronic control unit, and this control is done by the help of a few sensors. Question is, if those sensors start malfunctioning, and then what will be the consequences. So, ECU is housed with a few sensors. Those sensors, upon receiving signals, send out electric or voltage signal output. The question is, there is a high chance that after a few cycles of operation or a few days of operation, sensor might start malfunctioning. In such a case, adequate arrangement should be there in the ECU itself, so as to ensure safety operation of the engine. So, to account for all these, to account for this abnormality, that sensor might start malfunctioning or sensors might malfunctioning, there are a few additional functionalities of electronic control unit, and we have listed down those additional functionalities in the previous class. One such functionality was replacement of default signal or default values of faulty signal generated from the temperature sensor. The temperature sensor, that means though we did not discuss this using a schematic depiction, we shall discuss that aspect today, but temperature sensors, typically ambient air sensor, which is integrated with the intake manifold, and also cooling water jacket is also having a temperature sensor. So, now sensing temperature of both cooling water, temperature of coolant in the cooling water jacket, and also sensing the temperature of air which will be drawn into the engine cylinder, ECU control or adjust, because you all know that mass flow rate of air depend on what, that is rho swept volume into volumetric efficiency, this is rho I. So, that is density of the air which will be drawn into the engine cylinder. So, this is volumetric efficiency, and this is swept volume, and this is essentially P by RTI or Pi by RTI. So, if we can monitor the temperature of ambient air, we also can control the mass flow rate of air that should be drawn into the engine cylinder, because this is directly related to the efficiency of the engine, right. So, what does it mean? So, sensors, that is cooling water temperature and ambient air temperature sensors also should be functional always, but as I said you, there might be a situation when temperature sensor will not function properly. In such a case, adequate preventive measure will be taken by the ECU or engine management system, and that alternative arrangement is replacement of default values of faulty signal of the temperature sensor. Typically, temperature sensors are there in intake manifold and in the cooling water jacket. So, what ECU does, if sensor fails, engine controls unit or electronic control units should be able to run the engine without inviting additional problem. So, by how it does? So, it substitutes. So, if sensor fails, temperature sensor fails, it substitute a fixed value for that sensor input, sends out a faulty signal, and continues to monitor the sensor if or continue to monitor the incorrect sensor input. So, what ECU does? If a particular sensor start malfunctioning, ECU will be having adequate arrangement or adequate functionality, so that ECU will be able to substitute a fixed value of that sensor's input, and then send out a fault code and continues to monitor the incorrect sensor input. If sensor resumes or returns to its normal activity, then again engine will return to its normal activities. So, that is what we have discussed in the last class. So, I discussed that one of the functionality is to replacement of the default value of faulty signal generated from the temperature sensor. So, this is an important issue. So, that is also taken care by the ECU. By how? That is what I have discussed today. Now, with this let us discuss about. So, if I write replacement of default values of faulty signals. Generated from temperature sensors rather, typically ambient air and coolant. Okay. And this is what is done by ECU, and today we have discussed by how it by how ECU or engine management system takes care of it. Okay. So, with this let us discuss about a basic control unit. As I said you that ECU or engine management system has manifold application essentially to maintain or to control fuel injection, to control spark advancement, to control emission, to control speed, so many. Now, this is a basic schematic depiction. I will try to describe the functionality of ECU taking this example. So, what you can see from this example is that this is engine cylinder, and this is cooling water jacket. Okay. And you can see that this cooling water jacket is having a sensor, the temperature sensor, and which is connected to ECU. Now, question is ECU on receiving input signal. So, ECU will receive input signal from this temperature sensor, and then again will send some feedback. So, this pressure, temperature, you can see these are the input, because these are directly related to mass flow rate of incoming air. So, this pressure sensor, temperature sensor, these two sensors are connected to intake manifold, and also this is a sensor which is used to control throttle opening area, throttle valve adjustment, and this is another sensor which controls speed of the engine. So, this is N, which is, so P and T, these two sensors are, so input signal of P and T are the from the sensors are integrated to the intake manifold. Okay. Now, if we go back to previous slide, we have written over here that temperature is very important to be monitored continuously. Pressure of the ambient air should be monitored continuously, so as to ensure that proper amount of mass flow rate or proper amount of air should be drawn into the engine cylinder. If airflow or intake air or amount of air should be drawn into the engine cylinder is not at par with theoretically calculated value, then it should have detrimental consequences. Either combustion should not be complete or efficient, and then exhaust gas that will come out will be having either with rich in oxygen, that also will have the overheat, that also will lead to run catalytic converter beyond its optimum efficiency, and most importantly power output will be less. So, this is very important. So, receiving signal from these two sensors, ECU will adjust, ECU will generate some output and will provide input to the throttle valve. So, if temperature, pressure, that input should goes to ECU. Knowing exact input, ECU will try to give some output signal to the throttle valve, so that if necessary throttle valve opening area should be adjusted so as to ensure adequate amount of air should be drawn into the engine cylinder. Similarly, say for example, if this RPM, that is speed of the engine, if engine decelerates or if engine accelerates from its normal condition, then again engine will allow this throttle valve, engine will give some signal to throttle valve to open or to control its opening area, essentially to allow to adjust amount of air or air fuel mixture to be drawn into the engine cylinder. So, this is one thing. Now, question is, if it is okay, if it is SI engine, then certainly air fuel mixture should be controlled. If it is a CI engine or even for modern SI engines, then most of the cases fuel is sprayed into the engine cylinder, multi-port fuel injection system. So, what will happen that receiving signals from speed control speed sensor, then this ECU will provide some signal to the pump, which will deliver fuel from fuel reservoir into this fuel nozzle. So, this is fuel nozzle. Okay. Now, so you can see that fuel pump receives or takes fuel from this fuel reservoir, and then pumps that pump is responsible to deliver fuel through fuel filter and through fuel pressure regulator into this fuel injector. Now, for any reason, if we need to supply more amount of fuel, or if for any reason if we need to restrict the amount of fuel to be supplied by the fuel injector, what it does, ECU gives an signal to the kind of this fuel pressure regulator or fuel pump, that and also through this throttle opening area, if pump will deliver always certain amount of fuel. Now, if that amount of fuel is not needed by the engine at any particular instant of time, then that information will be provided by the ECU to this fuel pressure regulator, and additional amount of fuel should be again back to the fuel reservoir. So, this electronic control unit, which is kind of centralized, which is used to monitor the activities of several subsystems, has made a significant contribution to the reduced fuel emission and improved efficiency. So, this is what we have discussed about fuel injection system. It is not only fuel injection system, as I said you, that even if it is, if the temperature sensor which is attached to this cooling water jacket receiving signal from this cooling water temperature, if the temperature is high, then again that means combustion is becoming more, or maybe the fuel air ratio which is lean, so or if fuel air ratio is rich. So, that means engine sensor, the cooling temperature sensor which is attached to cooling water jacket will provide, it has some range of for its optimal operation of the engine. Now, if the temperature recorded by that sensor is beyond that value, then certainly ECU will take preventive measure so as to control the combustion rate, and which in turn will ensure temperature of the cylinder wall, temperature of the piston face will be under control. So, this is essentially a schematic depiction of a particular of ECU or engine management system, and depicting or with the help of this schematic depiction we have tried to illustrate the functionalities of an ECU or engine management system. So, this is not only this, there are many other sensors, though I have tried to represent entire things using this block diagram, but in reality it is very complex. And as I said you, that speed sensor is basically engine speed. So, that should be able to sense the RPM of the engine, and if the RPM is reduced or RPM increases, so that again should be taken care by the ECU, and the ECU what it will do, it will control the throttle opening area to, or it will control the fuel amount of fuel to be supplied into the engine, so as to maintain the speed of the engine at its design value. So, with this let us now move to discuss about control system. So, now today our focus is to discuss about different types of control system. Now, before coming to classify different types of control system, let us discuss about what is control theory. So, control theory any control system would or will work using or based on the control theory. So, without violating or with rather I should say violating the understanding of control theory, nobody can design control system. So, whenever someone is trying to design a control system like electronic control unit, it should be based on the control theory. So, what is control theory pertaining to the discussion what we are having today? That control theory is a branch of engineering and mathematics that deals with how to control a system or systems to get desired output. So, or to obtain desired output. So, what is, let me repeat once again, control theory is a branch of engineering and mathematics that deals with how to control a system or how to control systems and to obtain desired output. So, if I write this definition, control theory is a branch of engineering and mathematics that deals with how to control systems and to obtain desired output. Okay. So, this is the control this is the control theory. Now, any control system will be based on control theory. Any control system is reliant on control theory. Violating control theory, no control system can be designed, and forget about the working capability of any control system. So, now the this is control theory, but we shall discuss about control system. So, the system, any system should be controlled like engine system. So, if we need to control the engine system, the system that is being controlled is called plant. So, basically if we need to control the engine system is known as or is called plant. So, let me write here the system which is being controlled is known or called as plant, and the devices which are used to control the plant or system known as controllers. So, plant and controllers, these two are important. So, that system being controlled, the system that is being controlled. So, the system that is being controlled is called the plant, and the devices which are used to control the plant are known as controller. So, are known as controller. There are two different basic types of control system. What are those? So, if we write control system, two different types. One is open loop control system, and second one is closed loop control system, sometimes also known as feedback control system. So, let us discuss these two systems one by one. So, what is open loop control system? So, if we discuss this control system first, then let me discuss with using the block diagram. Open loop or open type control system. Okay. If we try to recall the definition of control theory, and then what we have discussed, that the system that is being controlled is called plant. So, we will have a plant which should be under control. So, this is plant. So, if we need to control the plant or control a system, then there we need a few devices. So, if we have the block diagram, so those devices are known as controllers. So, receiving signal, so these are plant input. These controllers will drive the plant. So, plant will receive some input from the controller. So, these inputs are plant inputs, and again these controllers will receive some input from the environment, from the practical scenario. So, these controllers will receive some inputs. So, these are some inputs, and so controllers will receive some input, and based on these inputs controllers will give some inputs to the plant, and then we will be getting output or rather system output. Okay. So, this is the block diagram of a simple or open loop or open type control system. So, this is the most basic type, and it has least amount of functionalities that you can see from the block diagram itself. So, what it does, essentially for this particular type of control system, the plant is a desired output is fed into the plant. So, let me repeat once again. Pertaining to this system, a desired output is fed into the plant. Controllers provide some input to drive the plant to obtain that output, right. I will try to explain this taking an example. So, again I am repeating, this is the most basic type, and from the block diagram itself you can understand that this particular system has least functionalities. What this system is reliant on some an important aspect, that the plant is fed or the desired output is fed into this plant or system. So, a desired output, sometimes also known as reference, is fed into the plant. Controllers receiving some inputs, whatever may be the input from the environment, controller will give some input to the plants to drive it, or controller will drive the plant providing some inputs, and then the objective would be to get system output, but the output is always fed into the system, right. So, this is the basic type, that is open type control system. But you can see this particular type of control system is having one important drawback. What is that? It has no provision of receiving feedback. So, it will certainly give some output, because already we had the plant is given some reference or desired output, though the plant will run receiving some input from the inputs from the controller, but essentially output should be that desired output, right. So, there is no feedback in this control system, and it is because of this feedback, the problem of this system is the lack of feedback, or that if, since there is no feedback, system is unable to react to changes in its environment condition. So, that means I will try to explain this taking an example. So, since there is no provision of receiving feedback, and it is because of this the system is unable to react to changes in its environment, as there is no way of knowing what the plant is actually doing, right. So, since no feedback, there is no provision of receiving feedback to the plant, there is no way of knowing what the plant is actually doing, right. And since there is no way of knowing what the plant is actually doing, no matter whatever changes are there in the environment or outside, it will always provide the desired output, right. So, let us try to explain this taking an example, rather we can try to illustrate this type of system with the help of an example. In a cruise control system of a car, what is cruise control? Cruise is essentially an electronic device that monitors the throttle opening area so as to maintain a constant speed. So, in a cruise control of a car, that means if the car is having a cruise control, cruise is an electronic device that monitors throttle opening area so as to maintain a constant speed. So, in a cruise control car, if driver sets the speed of the car is 50 km/h, say for example, that is the desired output. So, a driver sets the speed of a car 50 km/h, and that is the output fed into this system, desired output fed into this system. No matter any changes will be there in the environment or outside, plant will not understand. So, because it has no way of knowing what exactly plant is doing. So, what we will be having, say for example, if the car, so long as the car runs on a straight road, it has no problem. The car will be having, or car will be able to maintain a constant speed of 50 km/h. Now, if the car needs to uphill, then certainly it will decelerate, engine speed will reduce, and if engine speed reduces, so control the electronic control unit or electronic engine management system will be able to provide some feedback to the throttle valve or sensor which is there in the fuel injection system to provide or to supply additional amount of fuel or additional amount of air fuel mixture, so as to have more torque will be developed. But that feedback is not there due to the lack of this feedback system. These systems are not used or can be used under certain operating condition only. So, system with the open type or open loop control system cannot be used under certain conditions. We shall discuss those conditions. So, what you can understand that the lack of feedback of this particular system does not allow this particular system to be used under in all conditions rather. So, ECU is not correcting, electronic control unit for this particular type of system is not correcting the air fuel ratio. As I said you, if the car needs to uphill, certainly it will decelerate. So, speed won't be 50 km per hour, but if we need to maintain the same speed, certainly we need to supply additional amount of air fuel mixture to the combustion chamber, right. That information is not given to the controller because the controller does not know what plant is actually doing, right. So, because the plant is fed with the desired output, that is 50 km per hour. So, ECU is not correcting the air fuel mixture, or even if sensor of the exhaust gas oxygen sensor, if that that sensor even provide some input to the ECU, ECU will not be able to correct the air fuel mixture. So, considering this particular control system or system with this particular type of control cannot be used under in different conditions, and those conditions are open type system are not recommended for the following conditions. Number 1 is cold start, number 2 is engine starting, number 3 is medium to heavy load condition. So, if the engine needs to supply or I should say not medium to heavy load, I should write operation. So, under these conditions a system equipped with open type control unit or open type control unit is not recommended and for this for these 3 operations or conditions for any system. So, system equipped with open type control cannot run with full efficiency or without any trouble under these 3 conditions, that is engine starting, cold start and for medium to heavy load operation. So, now let us discuss about the next one, that is closed loop control. Control system or feedback control. So, let us discuss about this type using block diagram. So, we have the plant and then we have system output, right. So, we have system output. So, this is the system output. Then again we have plant inputs. Then controllers will provide some inputs to the plant, and that is plant, those are plant inputs. So, this is controllers. Now, this is very important. So, we have inputs. Now, this is a closed type or closed loop. So, we have, rather we should design this particular type taking the feedback of the environment into account, so as to run the engine always with its best performance with reduced emission level. So, that means there is a provision of taking feedback what plant is doing. So, as I told you in the previous case, controller did not know what plant is actually doing, and it is because of this situation or lack of feedback from the plant output, controller won't be able to control the plant output, and plant always will give desired output which is already fed into the plant. So, in this case, receiving, if I here some sensors will be there, and sensors will, this sensor will correct or rectify something, and this will go here. So, measured output. So, either or plus, right. So, this is what is, and this is the measured error. So, I should write using this. So, what we can see from this block diagram, except the loop. So, if I now mark here, except this particular loop, that is feedback loop. Okay. Except for this loop, the block diagram looks like an open type control system, right. So, what is the speciality of this particular feedback loop? So, as I said you that in open type it is not possible to receive feedback from from the environment. Now, for this case what we can see, or from the schematic depiction we can see that feedback loop allows the system to basically get some signal, get some input from the environment. So, this feedback loop allows the system for changing condition by utilizing some sensors, is it, because there are some sensors, by utilizing some sensor that monitors engine operating conditions. So, that means all these inputs we will be receiving like pressure, like temperature, like speed, temperature of cooling water jacket, temperature of ambient air, pressure of ambient air. So, all these inputs are from the engine operating condition. So, and those inputs are provided to the controllers. If needed, controllers will adjust, and then controllers will give some input to run the plant, and we will be getting always, or we will be obtaining always desired output. Now, this feedback loop allows the system for changing condition, allows the system to adjust for changing condition. So, this feedback loop allows the system to adjust for changing condition by utilizing a few sensors that monitors the engine operating condition like speed, throttle valve location, throttle valve control, and also coolant temperature. So, engine operating condition means speed, coolant temperature, air temperature and throttle valve position. So, these sensors are employed in this feedback loop essentially to monitor the engine operating condition, and it is because of this what we can see, if the output is getting deviated from the desired output, then the sensors will give some measured output to the input and then either added or subtracted from the measured value, that is reference value, and then that information is given to the controller and then controller drives the plant giving some input. So, this is basically the closed type control system. Now, what we can see that the provision of this feedback system has made significant contribution to the efficiency and emission level of the engine. By how? So, let us try to discuss this with the help of an example. Rather, we can illustrate this particular type of sensor with the help of an example. Say if electronic control unit is responsible to adjust the air fuel ratio, right, because air fuel ratio is essential to have proper combustion. If the combustion is proper, torque generated will be proper and will be getting proper output. So, if electronic control unit which is responsible to provide or to supply proper air fuel or correct or stoichiometric air fuel ratio to the engine, then engine will run always with its designed output. Now, electronic control unit will be receiving some signal from the exhaust gas oxygen sensor. So, what is exhaust gas oxygen sensor? Because in the exhaust manifold there is a sensor and that sensor is called exhaust gas oxygen sensor. What it does? It senses the concentration level of oxygen with the exhaust gases or in the exhaust gases. Now, that sensor will give some input to the electronic control unit. Say for example, if the oxygen level in the exhaust gases is very high or very less, then that information will be received by the electronic control unit and that electronic control unit will try to adjust the fuel or the fuel injection period. Say for example, if the oxygen level is more in the combustion gases, what does it indicate? It indicates that in the air fuel mixture that was supplied into the engine, amount of fuel was less. So, combustion was improper and excess amount of oxygen comes out with the combustion gases. So, then ECU will try to monitor that and ECU will electronic control unit or engine management system will give some signal, output signal to the sensor which is attached to the fuel injector, and ECU will give an indication that please try to supply more amount of fuel so as to adequate or excess amount of air can be combusted with the excess amount or that additional amount of fuel to be supplied. Now, in any case, if the signal received by the exhaust gas oxygen sensor is such that oxygen level is very less in the exhaust gases, then that means the fuel was rich in the air fuel mixture. So, what again ECU will do? ECU will try to put or try to give some signal to the intake manifold or throttle valve to supply more amount of air, so as to excess amount of fuel that is there will be able to combust with the additional amount of air to be supplied, and hence the oxygen amount or the level of oxygen or concentration level of oxygen should be optimum with the or in the exhaust gases. So, this is the idea of closed loop control system. That means, sensing the oxygen level or oxygen concentration in the combustion gases by the exhaust gas oxygen sensor, ECU will be able to control either the fuel injection period or the throttle valve, so as to maintain the air fuel ratio to be always stoichiometric, ensuring combustion is proper and in such a case catalytic conversion efficiency will be optimum. So, this is what is very important to know. So, what you can understand in the former case we had seen that even when engine is upfilling, then speed will reduce, engine will decelerate, but there is no there is no way of giving that input to the plant, to the controllers, because controller does not know what plant is actually doing, right. So, because of the lack of this information, engine will not be able to attain the desired output, right. But for the later one, that is closed type control system, we had seen that receiving some feedback that allows the system to adjust for changing condition using this set of sensors to operate engine or to monitor engine operating conditions. That means, either to increase the injection period, fuel injection period or fuel injection time, or is to increase the throttle valve position or opening area, so that stoichiometric air fuel ratio would be always supplied to the engine, and then efficiency will be maximum. Oxygen content in the combustion gases will not be either high or less, and catalytic conversion efficiency also will be maximum. So, this is all about these two different types of sensors. In most of the cases, in most of the engines, closed loop controllers are complemented with feed forward aspects, and certainly to improve residence time. Let me tell you one thing, though electronic control unit is capable of doing all these things, but the feedback loop allows even more finer control of the entire system. So, we have discussed about two different types of control system today, but beyond this control system can be further classified into two subcategories, that is called, one is memory based control and another one is adaptive control system. So, we shall discuss these two different types in the next class, and with this I stop here today. Thank you.